Now let's jump into our third problem-solving strategy of drawing a diagram. So when you're thinking about this problem-solving strategy, you want to draw a diagram or picture that represents the data of the problem as accurately as possible. And what we're going to do for this problem, you might not typically think of as drawing a diagram, but it actually is. So let's take a look at an example. So here's the problem we're given. It says in a stock car race, the first 5 finishers in some order were a Ford, a Pontiac, a Chevrolet, a Buick, and a Dodge. So I'm going to be thinking about Polya's first principle, making sure I understand the problem. We had a race between 5 cars, and A, B, C, and D here are telling me some clues about the order that they finished in. So the Ford finished 7 seconds before the Chevy. That's what I see here. The Pontiac finished 6 seconds after the Buick. The Dodge finished 8 seconds after the Buick. The Chevrolet finished 2 seconds before the Pontiac. And what we're actually trying to do here is to figure out the order that these cars finished in. So I understand the problem. I need to figure out who finished first, second, third, fourth, and fifth, okay, of these cars. So now I need to devise my plan. I told you we're going to be drawing a diagram, so now I need to carry out that plan, okay? And like I said before, you might not typically think of this as a diagram, but it completely counts. I'm going to draw a number line. So there's my finish line, okay? And I'm going to place each of these cars along the number line to see which order they finished in. So to start with my first clue here, the Ford finished 7 seconds before the Chevy. So I'm going to place my Chevy, and then I know that the Ford finished 7 seconds before the Chevy. So I'm going to jump 7. 1, 2, 3, 4, 5, 6, 7, right? The Ford's going to be closer to the finish line, 7 seconds closer to the finish line, in fact, because the Ford finished 7 seconds before the Chevy. So now I need to go through my clues and I need to find another clue that either involves the Chevy or the Ford because they've already been placed, okay? So let's look at clue B. The Pontiac finished 6 seconds after the Buick. Well, that says nothing about the Chevy or Ford, so I can't use that yet. The Dodge finished 8 seconds after the Buick. Again, that says nothing about the Chevy or Ford, so I can't use that clue yet. Let's look at clue D. The Chevrolet finished 2 seconds before the Pontiac. So that means that my Chevy is 2 seconds closer to the finish line than the Pontiac. So I'm going to go 1, 2, and now I can place my Pontiac. All right, and now I'm going to go back to that second clue because I now have placed the Pontiac, so I can deal with that second clue, right? So the Pontiac finished 6 seconds after the Buick, okay? So I've placed my Pontiac, and so my Buick came in 6 seconds ahead of it. So now I'm going to jump 1, 2, 3, 4, 5, 6, and now I can place my Buick, right? Because the Pontiac finished 6 seconds after it, which means my Buick's closer to the finish line. And now I can do this last clue. The Dodge finished 8 seconds after the Buick. Okay, so here's my Buick. The Dodge came in 8 seconds after it. So 1, 2, 3, 4, 5, 6, 7, 8. So here is my Dodge, all right? So now I know that this is the order that these cars came in, and I did it simply by drawing a number line diagram. So now the last thing I want to talk about, I want to ask you 2 questions. We, of course, have to use Polya's fourth principle and sort of think about the strategy we just used of drawing a diagram, and did it work well? You should always ask yourself that. Was this an effective strategy? Is there something I could change about it? Or did this do the job? And honestly, I think this did the job very well, but it's always worth asking the question. And then just because I'm always asking you guys to think about this, what manipulatives could you use in the classroom? And there's a variety of ways you could show this in the classroom, and a lot of different learning modalities that you could use. So for really young kids, you could have them dress up as the cars and then literally place themselves on a giant number line on the floor. That's very tactile, kinesthetic. It's getting them moving, so it's involving a lot of movement, which they need. For kids who are a little bit older, you could use toy cars and just place them on laminated number lines. And then for kids who are a little bit older than that, you could make it a bit more abstract and have them actually just, use note cards or sticky notes to place on a number line, either on the floor or on a piece of paper. And then no matter which strategy you use, you as the teacher can then show them how to transfer this onto paper. So, with the younger kids, they could act it out and place themselves on the number line, and then you could sit down in a group meeting and draw out the diagram and show them how making a diagram can be used to solve this problem. So there's a lot of different manipulatives you could use in the classroom. There's even more than I've listed here. There's a lot of ways. You don't have to use cars. You could use anything. You could use cubes on a number line, and each cube could be a car. So there's just so many ways that you can involve manipulatives for this, and we should just always be thinking about that.